Hello viewers, today we are going to see about off-wave rectifier using SCR. SCR means silicon controlled rectifier. So this is our load resistance. So we want DC current to flow through the resistor. Okay, let me explain the circuit. So here in India, this is AC source, AC power line source, which is 230 volt 50 hertz AC, and we have a transformer to step down the voltage. So it can be 110 volts, 60 volts, 40 volts, 22 volts, anything like that. 6 volts, 9 volts. So our idea is to step down the incoming AC to the required value. Okay. Now, this is our key component, which is SCR, silicon control rectifier. So here we give the gate current. This is a DC source. So we are giving a gate current to the SCR. Assume initially there is no gate current. So we all know that the characteristic curve of SCR, that is when there is no gate current, some leakage current will flow, and at one point all the four layers will has to break down and then it starts conducting. Okay, the response will be like this. This is forward voltage and this is forward current. But when we try to give a gate current, the breakdown will happen even at a lesser voltage. So this here gate current is 0. Here gate current 1, Ig1 is greater than Ig. So if you keep on increasing the gate current, it will start conducting. So in this case, what happens is, during positive offset, so in the transformer, when this end goes positive and negative like that, it keeps on going. The bottom end will go negative and positive. So assume that when this end is positive and this end is negative. So as such, SCR is forward biased. But if you give a gate current, the SCR starts conducting. That means if I say SCR starts conducting means you can view, I'm calling this as point A and this as point B. You can view A, B as a short circuit. That means it acts as a conductor and current will start flowing. That means this is positive, this is negative, current will go in this direction. When the negative half cycle, during negative half cycle, this end is negative and this end is positive. So during negative, this is reverse biased and the SCR will not conduct. So the idea is, what is the use of this gate? So by controlling the gate, the output, the input is a AC waveform, but output, if I don't use an SCR, if I use an ordinary PN diode, this is positive half cycle, the negative half cycle it won't conduct, and once again positive half cycle it will conduct. But the beauty of this gate current is, you can control the controlling angle. That means you can start, you can make the device to conduct at a particular gate current. That means here it will be off, at one particular moment it will start conducting. That means, so it will start conducting here. And this conduction angle can be adjusted with the help of gate current. You can make this here come down, or you can increase by increasing the gate current or decreasing the gate current. So what's the benefit? So this will be the conduction angle, even though at this point you see a full cycle, okay, positive and negative. That means this, but because this gate current is controlling the conduction angle, initially assume it is conducting at say 45 degrees. So after 45 only, the device will allow the current to flow through the device, SCR. So it will conduct like this. So what's the advantage of doing like this? The advantage is, whatever power requirement to the load can be controlled. Thereby, suppose especially if I use triac, that means in triac and all, it can be viewed as a two bidirectional SCRs. So you can control the load in both positive as well as in reverse direction. You can control the speed of the load, or you can make a lamp dimmer, you can increase the intensity of light or decrease the intensity of light. So previously, what's the advantage? The advantage is you can pay the EB bill only for this period. Whereas in the conventional, if you use a silicon diode, the entire cycle is being utilized. Okay. Whereas in this case, we are utilizing the power based on our requirement. Therefore, the amount of EB bill that we are going to pay will become less. That is one advantage. The other one is, by controlling the conduction angle, you can control the device at which point it has to, at which angle it has to conduct. So these are the some of the benefits of using an SCR. It's a power device. So to control the gate current, you have a variable resistor, and of course you have a DC supply to give the supply the gate current. So what happens during negative half cycle? The device in SCR will not conduct in the reverse bias, so it won't conduct. Once again, a positive half cycle will come, so the device. So the current through the load resistance is always unidirectional. Therefore, we can say it is DC. Of course, it's a pulsating DC, but then in that also we can control. We are able to control the angle of conduction of the device. So that's the, so next half cycle will not conduct, and once again this will start conducting after a certain angle, say 45 degree. So this is the way the circuit will work as an half-wave rectifier using SCR, silicon controlled rectifier. Hope I think you have understood the concept behind how SCR works by controlling the conduction angle, thereby controlling the power itself. Thanks for watching this video. Nandri.